having established that there are 4 different joints that we're going to talk about in the shoulder complex: sternoclavicular joint, the acromioclavicular joint, the glenohumeral joint, and the scapulothoracic joint. We're going to talk about the kinematics and briefly the arthrokinematics of each joint. I don't expect you to know right now the detailed convex concave relationships of each joint, even though they are featured in the book. I just want you to have a general idea about the movement of the joint, of each joint. So I want you to be able to identify the joint types and motions available at each joint. This scapulohumeral rhythm, what is it, and what is its significant to shoulder girdle function? And really, scapulohumeral rhythm is a fine example of the cooperation of the different joints in the shoulder girdle. Other than muscles, what are the stabilizing components of the glenohumeral joint? And we're going to talk about some of those in this section and some in the next section where we talk more specifically about ligaments. And then I want you to identify the linked joint motions of the shoulder complex. So by that, it's like when something happens at the glenohumeral joint, what is the accompanying motion that happens at the scapulothoracic joint? And we'll talk about it. So the shoulder complex really functions through the interactions of all 4 of those joints: sternoclavicular, acromioclavicular, glenohumeral, and scapulothoracic. So sternoclavicular, acromioclavicular, and glenohumeral are all traditional synovial joints with the joint capsule and all the stuff we've talked about with synovial joints. The scapulothoracic joint, on the other hand, is what's considered a functional joint. So it's not surrounded by a joint capsule. It's not the ends of 2 bones going together. It's a functional joint where one part of the body is moving on another part of the body. And it's the scapula moving on the rib cage. So a very different kind of joint, but very important to shoulder function. The sternoclavicular joint is a saddle joint with convex and concave surfaces on each of the joint's articular surfaces. So both sides have convex and both sides have concave. The saddle joint, it allows the sternoclavicular joint to move in all 3 planes. So the motions of the sternoclavicular joint include elevation and depression, and we'll talk about what those are, protraction, retraction, and axial rotation, which means it rotates along its long axis. And so it's an interesting movement. So really all movements of the shoulder girdle, like movements of the scapula and the clavicle and the glenohumeral joint, originate at the SC joint. So if your SC joint is not moving, it can significantly limit movement in other parts of your shoulder. So, who knew that that little joint was so important? But it is. It provides the only direct bony attachment of the upper extremity to the axial skeleton. It's super stable and has tons of ligamentous support, but it allows extensive mobility. So a lot of times when you're working with someone with a shoulder injury, and maybe you're doing some mobilizations, you're not just mobilizing the glenohumeral joint, you're also looking at the mobility of the sternoclavicular joint, the acromioclavicular joint, and the scapulothoracic joint. So all 4 joints are important for shoulder mobility. A lot of times you start with sternoclavicular movement and see what you get. So like I said, the sternoclavicular joint allows motion in all 3 cardinal planes. It's supported by a thick network of ligaments, a joint capsule, and just to make it interesting, it has an articular disc as well. So it has a high degree of stability. So fractures to the clavicle occur way more than dislocations to the sternoclavicular joint, because the sternoclavicular joint has got connective tissue really backing it up, really making it strong. And so what's going to give first? The weakest area. You go over the bars on your bike, you're not going to dislocate your SC joint, you're going to break your clavicle. So it being a saddle joint, it has 3 planes of motion, 3 degrees of freedom. elevation and depression, protraction, retraction, and axial rotation. So when you elevate your arm, and so when I say shoulder elevation or upper extremity elevation, that includes shoulder flexion, shoulder abduction, and scaption, which is in between those two in a plane that's even with the scapula. It's not one of the cardinal planes, it's an oblique plane. So whenever you elevate your arm, the clavicle has to rotate posteriorly to support that motion. So we can palpate it in lab, but if you put your fingers of your opposite hand on one clavicle and elevate your arm, you will feel the clavicle rotating posteriorly. And then when you release the arm and bring it back down, you will feel it rotating anteriorly. So it's pretty neat that we have all that motion in that tiny little joint, in that tiny little bone. So I like this picture because it shows all the planes of motion. So you can see that elevation and depression it's a near frontal plane movement with an anterior posterior axis. So it's like little wings going up, sort of, almost little angel wings. Protraction and retraction occurs in the horizontal plane about a vertical axis of rotation. So the protraction and retraction is like the tips, the acromial tips of the scapula moving anteriorly and posteriorly. So it's a rotation around a vertical axis going through the sternoclavicular joint. Pretty neat, right? Rotation, the clavicle rotates posteriorly about its longitudinal axis. So I don't have a clavicle with me, but I'm going to substitute with a radius because it's sort of similar. So it rotates posteriorly when you elevate your arm. As the shoulder abducts or flexes, the coracoclavicular ligament becomes taut and it spins the clavicle posteriorly. So we don't have a muscle that does that motion. It's an accessory motion that comes with other motions. And it happens because it tautens the ligament and spins the clavicle posteriorly. The clavicle rotates anteriorly back to its rest position as the shoulder is extended or adducted. So we do have the subclavius muscle, which is right inferior to the clavicle, and it's more of a stabilizer than anything, but it does help with that anterior rotation. You can do a nice, if you're working on shoulder flexion or abduction motion and you want to release that subclavius a little bit, you can do a nice pin and stretch. You hold the muscle right underneath the clavicle and have the person elevate their arm, and you're stretching that subclavius muscle. Love it. Most people like the way it feels too. So the scapulothoracic joint is not a true joint in the traditional sense. It's not a diarthrosis or an amphiarthrosis or a synarthrosis. It's a functional joint. So it's the junction between the anterior aspect of the scapula and the posterior aspect of the thorax, so the ribs. It typically describes the motion of the scapula relative to the posterior rib cage. So the scapula can move a lot of different ways on the posterior rib cage. So the motions at the scapulothoracic joint include elevation and depression. That's the scapula going superior, inferior. Retraction and protraction, that's scapula moving anterior and posterior along the rib cage. And upward and downward rotation, and that's what accompanies glenohumeral motion. It's the inferior angle of the scapula moving superiorly and then returning to its anatomical position. You can also think of the glenoid fossa rotating upward to catch rainwater and then rotating downward, if you want to think of it that way. And we'll talk more about upward and downward rotation. So scapular elevation involves the scapula sliding superiorly on the thorax. When you shrug your shoulders, that's what happens to your scapulae. Depression is when the scapula slides inferior, so it's returning to a resting position. So if you're doing shoulder rolls, you're doing a combination of different motions, but the scapula has to go up and down in order to do that, elevate and depress. I don't really expect you to know all the different arthrokinematics, but you could probably figure them out if you had to. But protraction is the motion of the scapulae sliding laterally on the thorax. So when you go and you give your friend a big hug, your scapulae have to slide laterally. So it's that horizontal adduction is accompanied by some scapular protraction. And then horizontal abduction of the glenohumeral joint is accompanied by scapular retraction. It's the movement of the scapulae towards the midline. Upward rotation occurs as the glenoid fossa rotates upward, or you can think of it as the inferior angle rotating upward. Downward rotation is an upwardly rotated scapula returning to its resting position. So looking at the glenoid fossa, that sort of gives you that upward, downward. So it rotates up, now it's a little cup, and then it rotates back to its resting position. The acromioclavicular joint is considered a planar joint because it just glides. So it can move in, it does have 2 degrees of freedom. Very small motion in the acromioclavicular joint, but it's transmitting some motion from the end of the scapula, or from the end of the clavicle to the scapula. It's created by the articulation between the lateral aspect of the clavicle, the acromial end of the clavicle, and the acromion process of the scapula. It links the motion of the scapula and the humerus to the lateral end of the clavicle. So it's a link in the chain, a link in the kinetic chain. You can think of it that way. And when you look, and we'll talk about this in the next section, but when you look at the ligamentous support for the acromioclavicular joint, it's significant. So the acromioclavicular joint, being a planar joint, it's glidy. So it can, it really allows motion in all 3 planes. It can do upward and downward rotation, rotation in the horizontal plane, and rotation in the sagittal plane. So really these movements serve to fine-tune the kinematic relationship between the scapula and the humerus. So it's just, they're kind of absorbing some of the motions between the scapula and the humerus. It allows the scapula to maintain firm contact with the posterior thorax, and that's important for stability when you think of it. So the glenohumeral joint, this is the one that we traditionally think of as our shoulder, but it's just one of the joints in the shoulder. It's the ball and socket joint. It's created by the articulation of the humeral head with the scapular fossa, the glenoid fossa of the scapula. It allows tons of motion in all 3 planes, but not very stable, because look how shallow that little glenoid fossa is. The rotator cuff muscles provide the primary stabilizing force for this joint. And probably you'll notice in physical therapy how common rotator cuff injuries are. So when your stabilizers aren't working, you have an unstable joint. So we work on rehabilitating rotator cuff injuries and surgeries all the time. So ball and socket, 3 degrees of freedom. So you notice that most of the joints in the shoulder have 3 degrees of freedom. That kind of makes sense, right? All 4 joints in the complex. Not all of them are big motions, but they're still 3 degrees of freedom. So primary motions, flexion and extension, abduction and adduction, and internal and external rotation. We also have the lovely addition of when we're 90 degrees abducted, we have horizontal adduction and abduction. So we can clap. It's not the only reason, but so glenohumeral abduction and adduction occur in the frontal plane about an anterior posterior axis. The glenohumeral joint allows about 120 degrees of abduction, and you get 60 degrees of scapular upward rotation, giving us our full 180 degrees of healthy shoulder abduction. I don't think my left shoulder is going to do that. It's not quite back to normal yet, but so we get 120 degrees from glenohumeral motion, and then we have to borrow 60 degrees from scapulothoracic motion to get up to that full 180. So glenohumeral flexion and extension occur in the sagittal plane. The humeral head spins about a relatively fixed axis. Interesting, right? There's about 120 degrees of flexion and 45 degrees of extension available in the glenohumeral joint. 180 degrees of shoulder flexion is obtained using 60 degrees of scapular upward rotation. So if you want to reach up to that top shelf, you need to use your scapula. The glenohumeral internal and external rotation occur in the horizontal plane about a vertical axis of rotation. In internal rotation, the anterior surface of the humerus rotates medially. In external rotation, the anterior surface rotates laterally. The convex humeral head rolls and slides in opposite directions on the concave glenoid fossa. So we know that because convex moving on concave, you get roll and slide in the opposite direction. It's rule number one. Convex concave rule number one. Horizontal adduction and abduction. It's a movement of the humerus towards the midline in the horizontal plane with the shoulder in roughly 90 degrees of abduction. So when you take your arms out to a T and bring them together in front of you, that's horizontal adduction. So lying on a bench doing dumbbell flies, that's horizontal adduction. Horizontal abduction is movement away from the midline in the horizontal plane. So these are extra motions that other joints don't have. We do lots of things with our shoulders.